Hello guys and welcome to a new video, and in this new video what I'm going to do is I'm going to do like a recap of what we have learned before. In the past I believe 4 videos I have configured authentication for Eigrp. I also did some route summarization, so we are going to do summarize some routes. We talk about stub routers, and we also did some passive interfaces. And let me see if I'm missing anything else. Authentication, and also one of the videos that I did was on unequal balance, load balance. So we are going to configure that as well, unequal load balance between two links. And as you can see, my topology, I already configured all the IP addresses. I have not configured EIGRP yet, but all the IP addresses are in there. These 4 IP addresses that we have over here that we're going to summarize our loopback address. And this one, this loopback address, yes, I did configure this loopback address over here. And this one is the one that we're going to ping. So we can do that on equal load balance. We're going to do that later on. So in this video, we are going to first start with configuring Eigrp, since I have not configured Eigrp on any of them. And to configure Eigrp, of course, is Eigrp router Eigrp 10. And remember, guys, that that number 10 needs to match for every single one of them. If you configure any other router with a different number, a different AS, it's not going to work. All right. So let's go ahead to network and let's add 172, that 30, 0, 0. Actually, what I want to do, the way that I want to add the networks, it's going to be like this, because it is best practice by Cisco. Cisco recommends to add it this way, and I know that they all end in 1 because I configure them all, of course. So I've added all these loopback addresses over here. Now let's go ahead and add the interfaces. So network 10.10.10.1, network 20.20.20.1, and last one is 192.168.10.0. This one is going to be wildcard of 3 because it ends the subnet, or the subnet mask for this one is 252, which the wildcard stands for 0.0.0.3. So let's go ahead and enter that right here. Okay, so that's great. Now let's go ahead to router 2 and let's configure Eigrp. On router Eigrp 10, like like I said before, it needs to match. Let's go ahead and network 10.10.10.2, which you have formed a neighbor relationship. There it is. We have formed a neighbor relationship. Let's check that. Do show IP Eigrp neighbor, and we have a neighbor at 10.10.10.1, which is router 1. Great. Now let's go ahead and add the other network, which is 30.30.30. That 30, that we can do a 0 over here, and then we can add, okay, let's do it again. Sorry for that, guys. 30.30.30, that's 0, and then just add the wildcard mask of 3. So we have add both of them, both interfaces. Now let's go ahead to router 4 and add these 3 IP addresses that we need to add. The first one being on fast internet 0/1, fast internet 0/0, and then the loopback address. Let's go ahead and do router Eigrp number 10 network. I'll just add it this way. Just different ways that you can add it. As you can see, we have forming a relationship, working great. Let's do 40.40.40.1. Great. Now let's go ahead and add the loopback address, which is network 4.4.4.4. Great. All right. So we have added the three IP addresses that needed to be done on router 4. Now let's go ahead to router 3 and router 2, 3 on router Eigrp 10 network 40.40.40.0. It's a different way that you can add it. You can see we have formed a relationship. Great. So in router 3, we need to add 40.40.40.40 and 20.20.20 networks. All right. And there you go. Form a relationship again. So network 192.168.20.1. There we go. And as you can see, I formed two neighbor relationship. One was coming from 40, coming from my neighbor 40.40.40.1, which is router 4. And then the next one, which came from my neighbor 20.20.21, which is router 1. Okay. And what I'm going to do is now, let's go to router 1. Let's end this. Let's do some show commands. So show IP route. And as you can see right here, I have a bunch of routes, but I want to be more specific. Show IP route, just Eigrp route. And from router 1, as you can see, we have a couple of routes. So we have a route to the 4 network over here via 20.20.22, which is the best route. It is saying that fast Ethernet 0/1 is the best route. Um, that's because, as you can see over here, if you come here and take a look at the network topology, you can see that the bandwidth for fast Ethernet 0/1 is actually 256, and for fast Ethernet 0/0, which could be another way to get there, is actually 128 bandwidth, and which is why, since it is slower than fast Ethernet 0/1, it is not in here. So it is not load balancing, and that's something that I want to do. I want to load balance that. And if we do a show IP Eigrp topology, we can see more information about it on it. Um, so if you go to the Fort network, you can see that we have two ways to get there, but the best way, which is it via 20.20.22, which is on this side, is going to be the only one showing in the IP route. Okay, only the best route is going to show in the IP route. Okay, and since this one is the best route, the fastest route, and the one with the lowest feasible distance, right? The feasible distance is 10, 17, 9, 90, 72. You can see here a lot lower, but you can see that this distance is the same distance, it's just a little bit faster to get there. So the feasible distance um, is lower. Okay, going this way than going that way, which is why we only have one successor over here, and the successor is 20.20.22. And then we have a feasible successor, which is 10.10.10.2. And a feasible successor, what that means is it is a backup route. So if whenever this one goes down, this one is going to take over. Okay, so that's what that means. But what I want to do is I want to do a low balance between both of them, since 128 is not really that bad compared to 256. So I still want to low balance between the two links, and we're gonna have to do some unequal load balance. And unequal load balance is it can only be done using Eigrp, because OSPF cannot do unequal load balance. OSPF only does equal load balance. Eigrp does equal load balance and unequal load balance. All right, so let's go ahead and fix that. Let's go ahead to config T. Let's go ahead to router Eigrp 10, and all you have to do is do a variance 2. And what this number 2 over here was going to do is going to time the feasible distance is going to multiply by 2. And since it's going to multiply by 2, what's going to do it is, let's pull up a calculator. If I know how to spell calculator, there we go. There we go. So let's say that the feasible distance, the FD right here, is equal to 10, 17, 90, 72. When I do this command or variance 2, it's going to say times 2 now. So the feasible distance is going to become 20, 35, 81, 44. And 20, 35, 81, 44 is going to be higher than this one over here. And since this successor is higher than the feasible successor, then it's going to say, whoa, this one is higher, and this one is the one, and this one is the successor. So what's going to happen is, since this one is higher, this one is also going to become a successor, and it's going to equal balance. It's going to send traffic both ways. Okay, and as you can see over here, let's take a look. When I did the show IP route EIGRP, you can see that it only show one way to get there, which it was via 2020 2022. But when I do this variance command over here, it's going to show me that there's going to be two ways via 2020-22 and 10-10-10-2 as well. All right, let's go ahead and do that and show IP show IP route EIGRP. There we go. Since I did that command, now we are doing some unequal load balancing because we are able to send um, via 2020-22 and via 10-10-10-2. And you can see that the feasible distance for um, for the fast Ethernet 0/1 is 10-17-90-72, and for the fast Ethernet 0/0 is 20-17-92-00. And but it is still says that even though it is slower to get to this, to send traffic this way, we're still going to send traffic this way, okay? Because we're doing unequal load balancing, all right? And we can check that by doing a trace route for that. Let's ping this IP address over here of router 4. And you can see that we are sending traffic via 20-20-22 and 10-10-10.2. And that means that we are doing some unequal load balancing. Great, 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 great. And also, let's see. Okay, this is router 1. Let's go ahead to router 4. Let's do some show IP route. Okay, when we do show IP route, let's do a show IP route only show EIGRP. Okay, so the 172.30.16 is working good the way it is sending it. Um, so what I want to do next is I want to do a stub route, and the one that is going to become the stub route is going to be router 5. Okay, and what a stub route is that it stops getting query. Okay, and a query is whenever something happens in the network, whenever something changes. Let's say that this loopback address goes down, or let's say that this interface right here, fast Ethernet 0/1, goes down. Um, router 1 is now going to send, or router 5 is not going to ask. It's not going to ask for this interface anymore. Whenever it goes down, it's not going to ask for it because it cannot reach it anymore. It's not going to ask for it because it's going to be a stub route. And a stub route stops receiving queries, and queries are updates of the network. So whenever something goes down in the network, um, whenever something goes down on the network or goes up, um, the EIGRP sends a message about that update. And when you become a stub route, um, a stop means that it stops receiving any information about EIGRP because you're like a dead end. Okay, you cannot become a backup. So why send you EIGRP queries, right? Why send you updates if you're like a dead end? And this is a good way to save query traffic. The less traffic that you have on the network, the better the network you are going to have. And that's why Eigrp came with this um, stub routing. And it is really easy to configure stub. All you have to do is let's go ahead to the router, exit. Let's do a router, Eigrp 10. Um, all you have to do is, let's see if I remember variance. So you have to do Eigrp stub, right? And it asks you like what do you want to set it for. If you only set Eigrp stub, what it's going to do is going to set it as connected, which means that it's only going to advertise connected routes, and also summary. It's going to advertise summary routes if you just set it like that. But if you want to do set it up to whatever you want, you could do that. So if you set it up to only connected, it's going to advertise connected routes. And you can also set up um, multiple stop options. You can do like summary and link map. And the only one that you cannot combine is receive only. Okay, because receive only is going to turn off everything. It's not going to send any queries. All right. So you can have a connected with summary, connected with static, a static with summary, a static with link map, and redistribute. Okay. So like I said, connected only advertise connected routes. Link map allow dynamic prefixes based on the link map. All right. Receive only. That means that we are not going to send in queries. We are only going to receive Eigrp messages. Redistributed is going to advertise redistributed routes. And that happens when we have OSPF and Eigrp, and we are going to actually configure Eigrp and OSPF so they can talk to each other. So whenever they're talking to each other, that is called a redistributed route. Another one is a static. It's going to, of course, advertise static routes, and summary is going to advertise summary routes, but we are going to leave it as a default. And like I said, the default is that is going to do connected route, and also it's going to do summary route. Let's see if we're able to do a do show run so we can take a look at it. Oops. Okay, here we go. And like I said earlier, whenever you leave it at for the as a default, the default is, am I missing it? Here we go. Whenever you set up just Eigrp stub, what it does is it uses connected and also summary routes. Great, great, great. Everything is working great. Now let's go to router 3. And in router 3, I want to set up a passive interface. All right, router 3, exit. Actually, let's go back to router Eigrp 10. Okay, so passive interfaces. What do passive interfaces do? So whenever you set up a passive interface, what happens is we stop sending or receiving any Eigrp packets. So if you set up fast Ethernet 1/0 as a passive interface, it makes sense because what you want, what's going to be connected to that interface is going to be a computer, and computers do not send any Eigrp packets because it is not a router, right? And that is a secure measure because um, whenever you only want a computer, whenever you don't want a router connected to a port, what you could do is set that port to be a passive interface, right? And a passive interface does not send or receive any Eigrp packets. So here we go, passive interface 1/0 or 1 or fast Ethernet 1/0. All right, there we go. So that is a passive interface. Great. So now another thing that I want to do is I want to configure, hmm, okay, I want to actually configure authentication um, with Eigrp. And a way you could do that is by using key strings and MD5. And it is a really easy to do it, a little bit easy. Not really that easy to be honest with you. You just have to do it a bunch of times and then you will get really good at it. So let's go ahead to router one. And what you need to do is you need to configure a keychain, and this keychain name needs to match for all of them. So let's configure a keychain and let's call it Cisco, right? Actually, this one does not need to match. You can name it whatever you want. It is only locally significant, all right? So let's go to keychain Cisco. After that, you need to give it a key, and the key for this one is 1. So this key, this number over here, does need to match the other routers. So we're going to authenticate via router 1 and 2, and we are router 1 and 3. That's the only ones that we're going to authenticate. And then after that, you need to give it a key string, and let's call it just top secret. Top secret, there we go. Now let's go ahead to interface fast Ethernet 0/0. And from here, what we need to do is go to IP authenticate, authentication, and mode is going to be Eigrp, and we're going to call the Eigrp autonomous system that we're going to be using, which is 10, and then call it MD5. After that, as you can see, the Eigrp neighbor relationship with 10, 10, 10, 2, which is router 2, came down because we are telling this fast Ethernet um, 0/0 to use MD5 to authenticate. Since router 2 is now using MD5 to authenticate, then that neighbor relationship comes down. Okay, so another command that you need to do is IP authenticate authentication. And then after that, we're going to use keychain, and we are going to call that keychain that we name it, which is Cisco. And then after that, keychain Cisco. I think I did that right. Yep, keychain Cisco. Let me see. Authentication, keychain. I thought we were supposed to call keychain Cisco. No, okay, keychain Eigrp, and the autonomous is 10. Oh, okay, at the end, this is where you have to add the keychain name, which is Cisco. There you go. So now let's go ahead to router 2 and let's authenticate Eigrp with MD5. So like I did on router 1, let's go ahead from um, the config mode. Let's go ahead to keychain. Let's call keychain and let's just call it Cisco key. This one is to match key 1, key string. Let's call it top secret as well. Top secret. That's great. Let's go ahead to interface fast Ethernet 0/1 or 0/0. I'm sorry for that. IP authentication. Authentication. This one is going to be mode Eigrp 10 MD5. The next command is IP authentication. And from here we gotta use keychain Eigrp 10, and then we call Cisco, right? And Cisco needs to match this one over here. There we go. And now we should have that. It didn't come up. Top secret. Fast Ethernet 0/0. So the neighbor relationship did not come up. Okay, let's go ahead to router 1 and see what I did wrong. So we name it keychain 10. That's good. Cisco. IP authentication mode, Eigrp 10. We did that. We use key string tap. Okay, so this one is not matching. As you can see, this one is taps 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 SCRET, and that's why it's not working. So what we could do is go exit, and let's do keychain again. Let's go to Cisco key number 1, and the key string is going to be top secret. Now it should come up. And there you go. Since now the key strings are matching, you can see that my neighbor relationship came up, which is great. So now let's stay here in router 1, and let's do another one, another authentication mode. And I'm going to use keychain number 2 now. So let's go ahead and exit. Keychain. Let's exit again. Let's do keychain, and let's call it Cisco 2, key 2, key string is top secret, top secret 2. Let's go ahead to interface fast Ethernet 0/1. Let's go IP authentication. Um, the authentication for this one, it is going to be the mode Eigrp 10 MD5. And there you go, it came down, authentication, key chain, Eigrp 10, and this one needs to match the keychain Cisco 2. Cisco 2. All right, so now let's go ahead to router 3. And from router 3, let's go ahead and exit. Let's do a keychain. We call it Cisco 2, I believe. Let's go ahead to router 1. Cisco 2. Yep. Cisco 2. Key is going to be 2. Key string is going to be top secret. If I know how to spell it, top secret 2, which is the one that we did over here. Yep, top secret 2, top secret 2. Great. Let's go to interface fast Ethernet 0/1. Let's go to IP authentication and mode Eigrp 10 MD5. IP authentication and key chain Eigrp 10, and then after that one we're going to end it with Cisco 2. Now we should be able to see that neighbor relationship. There it is. So now if we do show IP Eigrp neighbor, we should see that we have two neighbors, 20, 20, 21, which is router 1, and 40, 40, 41, which is router 4. All right, so in this video, guys, what we did was that we did not do any router summarization. I'll leave that for another time, but we did some stub routing. We also did passive interfaces. We did some unequal load balancing with a bandwidth of 128 and 256. And then we also, to end it, we did some MD5 um, authentication method with Eigrp and the key strings. Okay, guys, so thank you guys for watching. I hope you guys enjoy my videos, and if you guys enjoy my videos, go ahead and go to my Twitter account and follow me on Twitter if you have a Twitter account at CCNA Daily Tips. And if you do not have a Twitter account, create a Twitter account and then go ahead and follow me. Thank you guys for watching, and I'll see you in the next one. Bye bye.